Hello everyone, welcome back to BC Calculus. Today we're talking about lesson number 17, and in this video we're going to start talking about integration of trig functions using U-Substitution. This lesson has a lot of integration techniques into it, so we're going to have a lot of different conversations about how to integrate a lot of functions, but for this particular video we're just going to look at U-Substitution. Now, we've done this before with polynomials, and one of the things that's tricky about trig is it may not be blatantly obvious what u should be. So when you're looking at sine and cosine, and this is always the case, so for cosine 3x, sine 3x, whenever you do this, your u is going to be sine of 3x, okay? And then your derivative is going to be, or your du is going to be 3 cosine of 3x dx. All right, so we talked about that before. So we like this because we have the cosine, we have the 3x, and we have the dx. So just like in the previous examples of the U-substitution, we need to get rid of the 3, so we're going to divide both sides by 3. And so now du is going to represent all these things right here, right? So I'm going to go ahead and erase this. So du is going to represent the cosine of 3x and the dx. So if I start writing this out, I'm going to get 1/3. And then this is the u. And then all of this is the du. So we have rewritten this in a very simplistic way. So whenever you have sine and cosine being multiplied together, now yes, you could have absolutely made u cosine of 3x. You could have absolutely done that, and then you would have had a negative that you had to worry about. So there'd be a negative on the outside. So yes, you could also have been cosine of 3x. But I try to keep it as simple as possible. So if I have a cosine and a sine being multiplied together, I always make u equal to sine of 3x. So that way I don't have to worry about the negative. Once we do the problem, we're going to go ahead and start integrating. Right, the integration of u is just going to be u squared over 2 plus c. And they'll be multiplied together. And so we're going to go ahead and do 1/6 u squared plus c. And then our final answer for this problem is we're going to have to go back and replace u, right, u with what our function is, because if we're in terms of x. So u is going to be sine of 3x, and we want to square it, plus c, right, plus c. And yes, you could absolutely put sine of 3x parentheses 2. You could have written sine of 3x parentheses 2 as well. So both of these are correct answers for this problem. Okay? So now let's look at example number 2, and the only thing that we've changed here is now we've done a secant and a tangent instead of cosine and sine. Now, if you think about making u tangent of 3x, all right, so if you make the u tangent of 3x, which we're not going to do, right, so this is just going to be a little trial and error because sometimes we got to do that, then our du is going to be equal to secant squared of 3x times 3. Well, we only have one secant here. So if this had been a square, if this had been secant squared, then that's exactly what you would have to do. And that's why sometimes it's a little frustrating with these problems, is that you kind of sometimes have to just kind of do like a little trial and error thing. So let's make u equal to secant of 3x. Well, if I want to do that, then my derivative of secant of 3x is going to be secant 3x tangent 3x. Just again, we don't have another secant, right? We don't have another secant. So that's also not our best option. So then the other thing we can do here is, well, let's just go ahead and make u equal to our theta. Just our theta, 3x. So then our derivative is going to be 3 dx. And so we're going to go ahead and do the 1/3 du is equal to dx. Now, how did that help us out? How did that help us? Well, we have our 1/3, and we're going to integrate secant u tangent u du. Right, so we just went ahead and made this a u, and then dx is actually equal to du, and then we have the 1/3 right here. So why is this actually helpful? Because we actually know what trig function's derivative is secant tangent. We know that secant's derivative is secant tangent. So the integration of secant tangent is simply just equal to secant. It's just actually equal to secant. So that's pretty awesome. And so our final answer for this particular example is going to be secant, and again, I'm going to go ahead and replace my u with 3x plus c. So two really similar problems, just done in two completely different ways. All right. So if you guys look at example number 3, and I'm going to kind of keep this up for you. If you guys look at example number 3, your sine and cosine are being multiplied together. Now in this case, for this one, guys, yes, u will definitely have to be sine because it's raised to the third, right? It's cubed. So u is going to be equal to sine of x squared, right? Sine of x squared. And again, if you were to go look at the problem and do a wrong u, then your du will not match up, and you just got to keep going back to another problem, or to another. What am I trying to say here? If your u doesn't work out, then you may have to go and try to do another u or another u. And sometimes I just look in my head and I kind of say, okay, well, u is equal to sine of x squared. Well, the derivative is going to be cosine of x squared times 2x. So that's why that random x is right there. It's like, oh yeah, that's probably right. Also noticing that sine is cubed, therefore that's probably going to be my indicator that I want that as my u, right? So we want that as our u. So for this particular problem, we're going to go ahead and make sine equal to, or u equal to sine of x squared, and then du is going to be equal to the derivative of sine of x squared, which is cosine x squared times 2x dx. And right here, we are going to get rid of the 2. And we could just really quickly, I'll put the x in front of it right there for us. So I've got the x, so that's the du. I got the cosine of x squared, and I've got the dx. So all of that can be rewritten, right? All that can be rewritten. Again, I have my 1/2 in the front. So, and this is my u cubed, right? So u cubed, and then all the thing that's been marked out is simply what du is. So this crazy complicated thing is now just becomes 1/2 the integration of u cubed du. Okay, so now we just integrate that. We get u to the 4th over 4 plus c. And so we get 1/8 u to the 4 plus c. And then we're going to replace what our u is. Our u is going to be sine of x squared. And we're going to raise it to the 4th power plus c. So this answer is going to be what you see right here. Okay, so hopefully it's starting to make a little bit more sense. I'm always encouraging you guys, like as we're moving on to the next examples, to kind of think about what you think the u is going to be here. Right, so now we have the integration of cosine squared of x over x dx. So what do we think this u is going to be? Well, let's make it, if you say the u is cosine of the square root of x, well, that's wrong because there's no sine in this function. So it cannot be cosine of the square root of x. Well, the next obvious thing here is let's make u equal to theta, right? Let's make u equal to the square root of x. Well, the derivative of the square root of x is just 1 over 2 square root of x, right? And so if we go ahead and multiply by 2, oh, and this should be dx, right? Yes, dx. So guys, let's look at that. So 1 over the square root of x dx, well, that's exactly what this is right here, right? That's our du, what you see right there. It's our du. So when I look at this problem, I'm going to do 2, and I'm going to get the cosine of u du. So look at that for a second and see if that makes sense. That I made my u the square root of x because the derivative is right there, right? It's 1 over the square root of 1 over 2 square roots of x. And so all I have to do now is integrate this. And again, if I integrate cosine, I get positive sine plus c. And then I'm going to go ahead and replace sine, or the u, with the square root of x plus c. Okay. And there we go. That is how we do that problem. So again, just a little bit of trial and error for some of these questions right here. I'm going to do these 3 right here, and then I think that'll be enough for our first video. I think we'll have plenty of examples. So tangent of x dx. All right, so now this is actually one that there is no trig derivative that is actually tangent, right? And please don't think this is secant squared. We're not taking the derivative of tangent, we're integrating it. So what we're going to do here is we're going to rewrite this as sine of x over cosine of x dx. Okay? Now, this one's really important to understand. If I make u sine of x, all right? If I make u sine of x, my derivative is going to be cosine of x. So let's just, again, this is not the right thing to do, so we're just going to talk about it for a second, though. So if I make u sine of x, I make du equal to cosine of x dx. I don't have cosine of x here. I have 1 over cosine of x, right? I want cosine. So 1 over cosine. I've really got secant, right? I got a secant here. So that's why this is not the right way to do the problem. So let's make u equal to cosine of x. Well, the derivative of cosine of x is negative sine of x dx. And I have that, right? It's right here, sine x dx. So all I have to do is pull out a negative, and then I'm left with what I want for my u, right? This is my du right here. So when I look at the problem, it's going to be negative square root of, well, my top is du, and my bottom is going to be u. It's going to be u. Now, this is the first time we've talked about how to integrate this. When we have 1 over, and by the way, this can be rewritten as 1 over u du. Okay? So whenever we have 1 over some variable to the first degree, so this is u to the first power. Just really quickly, if I asked you guys to integrate 1 over x squared dx, what you would do is you would rewrite this as x to the negative 2 dx, and then you would add 1 to the power, right? So it'd be negative 2 plus 1, which would be negative 1, and then whatever this exponent right here is, you put it down there. That's how you do integration, right? That's exactly how you learn how to do integration. Well, now what happens when it's just to the first power? So I could rewrite this as x to the negative 1 dx, and then remember, if I want to integrate this, I have to add 1 to the power, so I get x to the 0 over 0. And that we can't do that. We can't not do that, because you can't divide by 0. So we cannot do that problem that way. So what do we do? Well, we learn that this is, I'm getting a little ahead of ourselves here, but this is actually going to be the natural log of the absolute value of x plus c. So whenever you're integrating, and again, this is only when the power is a 1. It's power of 1. So this is going to end up being the negative natural log of the absolute value of u plus c. All right, so 1 over x, 1 over u, 1 over t, whatever it is going to be the natural log of u. And so when we get this problem, we're going to get the natural log, negative natural log, and then our u ends up being cosine of x plus c. There we go. There we go. Now, I was not imagining the exam being this mean, but you could also say that the negative natural log of cosine of x is actually equal to the natural log of the secant of x plus c as well. Okay, because remember, you can pull this up. This could be raised to the negative 1 power. So you could drop it down to be 1 over cosine, and which will give you secant. So these are actually equal to each other, but I do not see them being mean and doing that problem like this. Okay, so I'm looking at the time on this video, so we're probably just going to do example number 6, and we're going to stop for this one. But with this one right here, we integrated e to the sine of x over secant x dx. And when we do this problem, we're going to get u is equal to, and so anytime that you are integrating e, and we really haven't talked about this, so again, we're getting a little ahead of ourselves here, but anytime you're integrating e to an exponent, let u be the exponent. Let u be the exponent. Because then the derivative of sine of x is actually going to be cosine of x dx. Okay, well, remember that 1 over secant is actually equal to cosine. So if I rewrote this, I actually have my du right here. So that actually works. That actually works for us. So don't forget that 1 over secant is the same thing as cosine. So then if I do this, I'm going to get e to the u, and then this whole thing right here is du. And so another thing that we need to, that we know, or we will learn later, but again, so I'm ahead of myself here, but these are just 2 really good examples, is that the integration of e to the x is actually just e to the x. So it's actually pretty awesome that that's the case, and then plus c. So this answer is going to be e, and then we're going to do sine of x plus c. So we'll do another example of this much later in the course. All right. So I think that's good for these problems. So these were all indefinite integrals. So I think that's kind of the helpful of what we're going to do here. So in the next video, we will talk about definite integrals for U-sub, and then I want to go into some more strategies on how to integrate some trig functions that is just for BC students. All right. So I'll see you guys in the next video.